computer. All right, so for today's class, we're looking at how to define, evaluate, and compare functions. We're also learning to use functions to model relationships between quantities. In order for us to do that, we are going to have to be able to plot points. We're also going to have to be able to just look at the points and figure out what the graph would look like. To start out, we are going to plot some points. So go ahead and get a piece of paper. You could do this while I'm doing it. Plotting points on a graph. And to continue, I'm going to draw my y-axis, and I'm going to label it y. Do this while I'm doing it so that you don't lose track. And then I'm going to draw my x-axis. So the vertical one is my y-axis and my horizontal line is my x-axis. Where both of them cross, that's 0. It's like putting two number lines together. The left side of the number line is negative and the right side of the number line is positive. So then if I'm labeling my x-axis, 1, 2, 3, 4, 5, 6. And I just want to ensure that I'm going to estimate so that it has equal amount of space in between it. All right. If we're using a graph paper, then we'd know the exact amount of space that's in between each number. But since we're not using a graph paper, we're going to try and make each space in between kind of similar. Then on the other side, that's the negative side. -1, -2, -3, -4, -5, and so forth. Actually, I'm going to put a line, arrow right here as well, and right here. Does anyone have any idea what the arrows mean? Zoom recording. So these arrows, it just means that the numbers keep going, 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 going. It's just that on our sheet, we won't have continuous paper. So we just put an arrow saying, you know what, this continues. So we have our x-axis, y-axis, and we label them. So now we're going to label the y-axis. And I'm using different colors just so that we could see them. All right, so 1, 2, 3, 4, and so forth. I can't put any more on there. And then on this side, it's going to be -1, -2, -3. So now we have gotten our graph. What if we have our table? We got a set of points. I'm going to put it right here in this corner. We say that's the domain. And that's the range. Remember, domain means the x values, range means the y values. So I'm going to put in a point right here. 1, and say it comes out to 3. 2 comes out to 5. 3 comes out to 7, and so forth. So then to plot my first points, the first one says 1, 3 up here. 1, 3. Boom. So the first one says 1, 3. So I'm going to plot that point. So I'm going to find 1 on the x-axis, which is right here. Because remember, domain means x. And then I'm going to find 3 on the y-axis. And 3 is up here. So now I need to figure out the 2 points, the points in between that, or the point in between that. So this point right here would be 1, 3, because it's in line with the 1 on the x-axis, but it's also in line with the 3 on the y-axis. Do you see that? Keep in mind, I didn't do 3, 1. That would be a completely different point. If I did 3, 1, I would have had to do where 3 right here and then 1 right here. That's completely different. Okay. Now, if I do 2, 5, I'm going to find 2 on the x-axis, and I'm going to find 5 on the y-axis. It's going to be somewhere up here, 5. I didn't put it on this, but if I keep going, it's going to be somewhere right here. So 2, 5. So then I have those 2 points. And then once I have those 2 points, a lot of times you want to plot at least 3 points. I also know based off how this constant of proportionality thing is going, I know that my other point would have been here. That would be 0, 0. If I had more points, it'd be 0, 0. So then since I have those points, I'm going to try and draw a straight line through it. I advise getting a ruler or something and just draw a straight line, connecting those 3 dots. And that's how you get your line. We do x first, and then the y value. The x-axis is the one that's horizontal, and the y-axis is the one that's vertical. Based off looking at these numbers, could you tell me what the equation for this one would be? Plus 2. Is it 3? Oh, something is missing. It'd be 2x plus 1, I think. Does that work? 2x plus 1. Yep. Which means this spot right here would have gone through this, not 0, 0. My bad. It would have gone through right here. That's supposed to be a straight line. This looks so bad. I'm so sorry. But that's that. So y equals 2x plus 1, because 2 times 1 is 2 plus 1, 3. 2 times 2 is 4 plus 1, 5. 2 times 3 is 6 plus 1, 7. And as we said, this one will be a linear function because it's a straight line, and it's also a function because it passes the vertical line test. Sometimes these numbers that I have in my table could be represented like this. in point form. So it doesn't have to be in a table. It could be like this as well. And then all I do is I know that the first number is X and the second number is Y. Always, first number is always X, second number is Y. So then I go on my X axis, I find 1. And then I go on my Y axis, I find 3. And then I kind of just match them up. So then I know my point is going to be right there.